I wanted to go over this particular problem. I thought
It looks like on trial, all of the math now has 10 attempts now.
Oh, so they fixed it already. All right, thank you. Okay, good. So they were fast. Thank you, Malik, for letting me know. But I kind of wanted to go over this problem. Basically because the answers do not include decimal places, so it'll be relatively easy. Okay, so but there's something that I want to say about this. There's something that I want to address with this problem. Okay. So what is that? So this is a problem in the book. So this is number 26. All right, and we have, okay, so maybe before I talk about that problem, it's okay, I'll just, so I have a resistor here of 1 ohm, and then there's a battery, and that's 20 volts. Then there's another resistor, which is 6 ohms, I believe, right? And then it goes down like this, that's point B, and then it goes like that, and we have a battery, and another resistor, and another resistor, and that's probably point A, and another resistor here, and the battery, whose EMF is E, that's not given. Actually, this one is E1 and this one is E2. And there's another resistor there. And is that it? I think so, right? So this is 2 ohms. Actually, I'm going to write it like this. This is 1 ohm. And then 1 and 4. This is 1 ohm, this is 4 ohms, right? Did I copy this thing down correctly? Actually, 6, 1, 4, 1, 1, 2. And I think we are told in the problem that the current here is 1 amp. And the current here is 2 amps. So just looking at this, 1 amp and this 2 amps. What's the current in this line and which way is it? In the middle. What's the current along that line and how big is it? It's gonna be
1 amp.
1 amp to the
Left.
To the left, exactly. And notice, these 2 amps will be here, right? 2 amps. You get 2 amps. You get 2 amps. And then the 2 amps comes here. And what happens is that it splits at point B such that 1 amp is going to go this way, right? And the other amp is going to go that way. So the current through that one is going to be 1 amp. The current through this one is going to be 1 amp. And the current through this resistor is also 1 amp, right? So I fill up all of that information just from looking at this current that was given in this line and this other current. From there, I can figure out that the current along this middle line is 1 amp to the left. So you have 2 amps, 2 amps, 2 amps, that then splits into 1 amp this way and the other amp this way, and then they 1 amp, and then they meet again, 2, 2, 2, 2, and then 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, and so on. Right? That's the very first thing. I mean, you could write down over here, and like, oh, this is I, and I'm gonna guess that it is to the left, right? You could look at this junction here and say this, and actually write down a junction rule and be formal about it. So you say, okay, I have 1 amp coming in this way. I don't know what this is. How about I guess that the current is this way and it's I2, which I don't know what it is, but I know that the current here is 2 amps, right? Suppose, I want to be formal about it and I write a junction rule for junction A. So then I would say the sum of the currents going in must equal the sum of the currents going out, right? So what's coming in according to my diagram? I have 1 amp coming in, and then going out I have 2 plus I2. So I solve for I2, and I get what? -1. And what does the minus sign tell me? That it is in the opposite direction that I guessed, because this was my guess. But it's still 1 amp, right? Which is, in other words, the current I2 over here is really 1 amp in the opposite direction that I guessed. So therefore, it has to be 1 amp this way. But given these numbers, we could just do this in our heads, right? I asked you right away, you gave me the right answer. Right? So first of all, you look at the circuit, they don't tell you current in other places, and they gave me this current, and they gave me this current, and from these 2 currents that were given in the problem, I can figure out for this particular problem right away what the current is everywhere else in the circuit. It's like I'm actually, in my head, I'm applying a junction rule. Yes? Okay. Notice that I guess the questions are how much is this voltage and how much is this voltage, right? Let's work on that. So how will I find those values for those voltages? So what do you think we should do?
Use the equations that you from yesterday.
Whose laws are those called?
Let me start over. Kirchhoff's law.
Kirchhoff's law. There are 2 of them: the loop rule and the junction rule. So which one should I use? The loop rule. Okay. Which loop should I use? Well, if I want to know E1, actually E stands for EMF. EMF is electromotive force. People call it EMF, which stands actually for electromotive force. Now, it's actually unfortunate because the E is because of this E here. The M is because of the motive, and the F is because of the force. And it's unfortunate that it is called, maybe not unfortunate, inconvenient, I would say, probably, that it is called an electromotive force because, well, if it's a force, the unit should be newtons, right? But it's not a force, right? It's a voltage. The units are in volts. It's just that you think of the voltage as, being associated with the electric field, which then exerts a force on the charges that move, right, in the circuit. So in that sense, yeah, it's the driver. The voltage is the source, right? That, of that energy that ends up driving the electrons in the circuit and establishing a current in the circuit. But actually, this quantity should not be called a force, right? It is because of that the electrons experience a force, but this quantity is not a force, it's a voltage. Maybe electromotive voltage is what it should have been called or something. But I guess when people were first learning about it, right, they said, oh, there's got to be something that's driving it, and it's this thing, and it's electromotive force. And instead of saying electromotive force, so many syllables, that people shortened it to EMF, the EMF. So EMF So you'll see this E a lot, and it just means voltage, right? Just think of it as a voltage. It's really what it is. The units are volts. So we have 3 batteries in this problem, in this circuit. We know the voltage of one of them, and we don't know the voltage of these 2. And we want to know what they are, right? So if I want to know E1, I have to take a loop, right? That includes the midline over here, this section in the middle. So which loop would you like me to take, and which direction would you like me to go? Clockwise, counterclockwise. I can choose a loop up here. I can choose a loop down here, or I can choose the loop all the way around. I have 3 choices. Which one would you like me to take? It's up to you. You tell me, and I'll just do whatever you want me to do.
Could we do a top loop going through the middle counterclockwise?
Okay, so, and I call that me number 1, just for reference, right? So that would be loop number 1. So the sum of the voltages around that loop must equal 0. Because I'm going to end up at the same spot where I'm going to start. Where would you like me to start in the loop? Where? At the top corner, right or left? Left? Is that what I heard? Okay, so I'm going to start right there. So this is me, and I'm going to start. And I'm going to go this way, right? That's me. We said counterclockwise, right? So here I am. So I'm going to write down the voltage across each one of these elements in this path. And since I'm going to end up where I started, I'm going to end up at the same potential where I started. So the overall change in potential has to be 0. That's why I put a 0 on the right-hand side of the equation. So I start here, right? So then I go down, down, down. Nothing happens. Turn left. Nothing happens. What should I write down when I go across this resistor? What's the voltage across it? How do you find the voltage across a resistor? What is it given by?
V equals IR.
I times R. So I multiply the current by the resistance. So it's 1 times 4. Now, should I write it as 1 times 4 a positive quantity, or should I write it as minus 1 times 4? I'm going to the right. Positive, right? Because if we go in the opposite direction as the current, then I'm going to locations where the potential is going to be lower. So it's a voltage drop. Actually, rise, a voltage rise, so it's positive. What do I write down when I go across this other resistor? Plus or minus? Plus, and I should write down what? 1 times 1. What should I write down when I go across this battery here? Should I say, and this is plus, and that's minus. I'm going from high to low potential, so I have to write minus. So, and what is this potential difference? E1, the unknown.
Why do we write the E like lower? Is it
What's that?
Why do we write the E kind of like epsilon, or what is? Why do we write the E just like funny, I guess?
Oh, it just, that's the notation that they use. I guess
Okay.
because capital E is electric field, and then, this is like a voltage.
Oh, okay.
I guess, it's, yeah. This could also mean energy, but, so. It's a Greek E. Minus E1, like that. And then I get to this corner, turn left. What should I write down when I go across this resistor?
Minus 6.
Minus 1 times 6. Keep going. And what should I write down when I go from minus to plus?
Plus 20 volts.
Plus 20. And then what should I write down when I go through this resistor?
Minus 1 times 1.
Minus 1 times 1, correct. And then I end up where I started, so all of that must be 0. And notice there's only one unknown. This is 4 plus 1 minus E minus 6 plus 20 minus 1 equals 0. So 4 plus 1 is 5, and 20 is 25, minus E, minus. And then I have a minus 6 and a minus 1, that's minus 7, right? Equals 0. So E equals 25 minus 7, is that 18? Did I do that right, or did I? So let's see, 4, 1 is 5, and minus 1, minus 2, 20, minus 2 is 18, yeah. Okay, so I know what this voltage is now. $18 volts. All right, now I need to find out this other voltage, E2. So I do another loop, rule. Which loop should it be? Should I go just down below, or should I go all the way around? Should I go clockwise, counterclockwise? Where do you want me to start? You tell me.
Could you do like a figure 8, or does that make it too complicated?
No, it's fine. I mean, where would you like me to start? Let's say I start over here.
Sure, so like go up and then to the left from B, and then kind of come around through the top battery.
Like that?
Yeah, and then once you get to B, make...
But I have to end up over there.
Right, so make a left when you get to B,
but then...
go back down.
I don't think you count those again.
Or does that not work?
He wants
No,
to keep
it does work. It does work, but it's like...
overcomplicated.
It makes a simple problem
It's like...
complicated.
It's like... You want to go from the 3rd floor of a building to the 5th floor, and you go down, and then you go to the 10th, and then you go to the 8th, and then you go to the 2nd, then you go to the basement, and then you go to, and then you end up where you end up.
Yeah.
But there's nothing wrong with it. There's just, you know, it's just you have to write down more terms, and it increases the possibilities of making a mistake somewhere, right? It's not more difficult. It's just longer.
numbers.
Could we just go from point start to B to A and then back to point start?
So, in other words, like this. Is that what you said?
Yeah.
All right, so we'll go counterclockwise again. So I'm going to call this loop number 2. The sum of the voltages equals 0. So I start here, right? That's me. And I go up, turn. What should I write down when I go across this battery? 18, right? Plus or minus? Plus, okay, and then I keep going. What should I write down when I go across this resistor in the same direction as the current? Minus 1 times 1. That's IR, right? And then what should I write down when I go across this other resistor? Minus 1 times 4. And then I get to junction A, turn left, turn go this way. And what should I write down when I go across this one? Minus 2 times 1? Yes. And when I go through this battery, what should I write down? I'm going to the right. Plus or minus? I'm going this way, from plus to minus. So I'm dropping in potential. So I write minus E2. And then what should I write down when I go across this resistor? Minus 2 times 2, right? And then I end up where I started, so that's 0. So this is 18 minus 1 minus 4 minus 2 minus 4 minus E2 equals 0. So that's 8, 10, 11. It looks like 7. $7 volts, right?
How can you annotate it like outside?
Yeah. You can say like that, me. Yeah. Something like that. Okay. So far, boring, I guess, right? You know, getting used to solving it. Me, if I were to do this problem, I would combine this resistor with this. They're in series, so I would replace these two resistors by 1, and I would call it 3 ohms. So it's going to be 2 times 3 is going to give me 6. And that's what you get from where is it?
Maybe the 2 and the 4.
Well, that was loop 2, though, right? So
Maybe
that
2
would
and
be the
2.
4 and the 2. So I would combine this with this into 1. I would combine this with this into 1. And I would combine this with this into 1. And then I'll just write less terms. Right? Yeah?
Is going across the battery not affected at all?
No, because this is in series with this because it's the same line along them, joining them. Whatever, if you have 1 amp over here, you're gonna have 1 amp through the battery, and you're gonna have 1 amp through that other resistor, because there isn't going to be a split or charge accumulating somewhere. It's gonna go through the battery. If this, yeah, so they are in series. Yes, I mean, just to save time, that's what I would do. So, if you don't mind, just so that I focus on something else that I want to address with this problem. If you don't mind, I already know what those two voltages are. So I would, how about I replace, well, I'll just do it over here again. Or I'll just do this is probably easier. 1 and 6 is 7, right? 4 and 1 is 5, right? And then 1 and 2 is 3. Yes, same problem, right? And I will get rid of this, and I will get rid of that. I don't really need this, and I don't need any of this. I don't need this anymore. I don't need this anymore. We're good? Okay, let's do something. What's the power supplied by the 20-volt battery? The current is 1 amp, right? So what will be the power supplied by the 20-volt battery? How do you calculate power?
Isn't
The current, I times delta V, correct. So it would be the current 1 multiplied by 20. So that would be 20 watts. Right? What is the power supplied by the 18-volt battery? Just, that would be what? It would be the current times the voltage, correct? Across the battery. The current through that battery is 1, and the voltage is 18, right? So this would be 18 watts, right? Yes? Okay. Before I consider this battery here, let me consider the resistors. What's the power dissipated by the resistors? The 7 ohm resistor. What's the power? What's the formula that I can use for the power dissipated by a resistor? I actually have 3 formulas. I can use, what are the 3 formulas for resistors? Power dissipated.
Current squared times resistance.
Current squared times resistance. What else?
Voltage squared divided by.
Voltage squared divided by resistance.
And
And current multiplied by the voltage, right?
yeah.
Well, since I know the currents and the resistances, how about I use current squared times the resistance? So I'll just write it like this, I squared R. So for the 7 ohm resistor, which is this one, the current through it is 1, and I square that and I multiply by R, which is 7, right? So that should be 7 watts, right? What about the 5 ohm resistor? I'm going to use the same thing, right? So what is the current through the 5 ohm resistor? 1, and then squared, multiplied by 5, right? And I still have the 3 ohm resistor, right? So what is the current through the 3 ohm resistor? 2, and I square that, and then I multiply by the resistance, which is 3. So that should be 4 times 3 is 12 watts. Correct? Now, can you see that I have a little problem over here? How much energy are these 2 batteries supplying? Together, just the 2 batteries. I haven't said anything about the other battery.
38 volts. I mean watts.
38 watts. And what about, well, the dissipative elements are the resistors, right? And all of them put together, I get 7 plus 7 is 14.
It should be 5. Yes.
Thank you. So 7 plus 5 is 12, plus 12 is
24.
24 watts. Those 2 batteries are supplying 38 watts. But remember how in that other problem, when we had only 1 battery and 3 resistors, right? The problem, the circuit that I considered was, we had a battery like this, and there was a resistor here, 2/3 of an ohm, and then 2 ohms, and then 4 ohms, right? And we did the energy, we showed that the energy supplied by the batteries is equal to the energy dissipated by the resistors, right? So we seem to have a little bit of a problem here. But I haven't said anything about this baby right here. Can you see? So notice, here's the point of this discussion. Can you see that this battery has the current through it so that it leaves the positive terminal? Can you see that for this other battery, the current leaves the positive terminal? But can you see that for this battery, the current is actually arriving at the positive terminal and leaving out the negative terminal, right? The 2 amps. So what's happening is that this battery is actually getting charged. It's not supplying energy, it's receiving energy. So let's figure out how much energy is being deposited into that battery. It will still be I times delta V. So it would be what? 2 times 7, which is 14. Isn't that the energy that we're missing over here? What are we missing if I consider this and this? We're missing 14 watts. Well, it's because in this circuit, because the current is this way through that battery, right? This battery is getting charged. It is not supplying energy. It's receiving energy. from the other two batteries. Yes? So that's one thing that I wanted you to notice, because if you did this problem and you just said, oh, the batteries are the suppliers of the energy, and you did this, right? And you included over here the power supplied by the battery, right? And then you did that, then you would add another 14 watts, and then you would have what? 52 watts? But wait a minute, the resistors are only dissipating 24 watts, so the energy equation doesn't work over here, right? The energy supplied by the batteries is not equal to the energy dissipated by the resistors, so there's a problem, right? And the solution to the problem is to realize that when the current is in this direction, so that the current, is, think of the current, right? Leaving the battery out the negative terminal, then this guy is actually receiving energy as opposed to putting out energy. So I'm going to write over here the power received, absorbed by the 7-volt battery. That's I times R, I times delta V, and that would be, the current through that one is 2 amps, and the voltage we calculated it to be 7 volts, so that's 14 watts. And now, if you add this 14 watts and this 24 watts, you get 38 watts, which is what the other two batteries are putting out. Okay, so that's the point of this problem, that if sometimes you learn the method, you learn how to figure out the currents and the voltages like we did in this example, but this is a type of analysis that you should do. If you compare the energy supply, it's the energy that's getting converted to, it's the chemical energy converted to electrical energy in these batteries, right? It doesn't add up to the electrical energy that the resistors are converting to other forms of energy. You're missing 14 watts. And it's because those other 14 watts from here are not being dissipated by the resistors, but they're actually going into the battery. So this battery, you say this battery is getting charged.
So if you switch the terminal of the last battery and the energy,
Then this is a supplier. If I switch it, then these currents are going to be different. So that the power supplied by this plus the power supplied by that. But then, notice what would happen. Could you have current going this way, current going this way, and current going this way?
No.
You're going to have like a lot of currents going in, but nothing going out. So then if you switch this, then one of these other ones will have to be charged. In this case, because notice, it's like you have these 3 batteries, and they're like saying, okay, the way that we have been connected over here, 2 are going to supply and 1 is going to have to be receiving energy. Well, which is the one receiving the energy? The weaker one. 20 volts, strong, it wins. 18 volts, okay, strong. 7 volts, okay, it's going to be the one. Now, the other thing that I would like to do is, that's called point B. Let me go back to the original circuit. This was 2 ohms, I think. And there was a 1 ohm over here. I think this was 4. And there was a 1 ohm over here, right? And this must have been a 6. And there was a 1 ohm over here. I don't need this, I don't need that. And I don't need that. Yes? Okay, so here's what I want to do. What if I consider a point in the circuit like, I'm going to put it right here. How about I call it C? I want another point. How about I put it here? D. And I want to measure the voltage between those 2 points, the potential difference between those 2 points. So can I erase this now? This is something interesting, right? I mean, you probably didn't think about it, but you know, it's the sort of thing that you learn when you don't just solve the homework and move on to the next problem, but you think about it, something is wrong over here, and then you realize, oh, this is what's happening instead. Okay, question, what is V minus V? So what would you like me to calculate? I'll let you choose. Do you want the potential at C minus the potential at D, or do you want the potential at D minus the potential at C? It's up to you. I don't care what you say.
D minus C.
D minus C. All right, so what is that? So VD minus VC. Right? So the way that I do it is like this. I look at this expression, and I see the minus sign over there, right? So then I go to that point, and I start a trip at that point, which is C. So I'm gonna start over here. That's like me. And I will move, walk, go to point D. I'm gonna go to this point, and when I get there, I'm gonna stop. Now, are those 2 points at the same potential? Not necessarily. So I'm just gonna do like a loop rule, except that I'm not gonna go around the loop. I'm gonna go from C to D. And I don't set that equal to 0. Whatever I get, that's the potential difference between those 2 points. So I'm gonna make a trip where I'm gonna start at point C, and I will stop when I get to point D. So now you choose the path. Which path would you like me to take? Would you like me to go to the right, down, and left, and stop? Would you like me to go left, down, right, and stop? I could also go left, up, right, down, and left, and then stop. It's up to you.
Right, down, and left.
Right, down, and left. So you want me to go like this and stop right there, right? Okay, let's do that. So I start to be here. So I will be going, this is me, in the opposite direction as that current when I go through that first resistor. So what is the potential across this resistor? It's just like a loop rule type of thing. What should I write down? I'm going in the opposite direction as the current.
Plus 1 times 1.
1 times 1, correct, plus. And then when I go through this battery, what will I write down? Plus 18 or minus 18?
Minus 18.
Minus 18. And then I get to B, I go down, nothing happens. I get to this point, go left. And what should I write down when I go through this resistor?
Plus 2 times 1.
Plus 2 times?
1, 2.
Yeah, plus 2 times 2. And then I get to point D and I stop. So what is this? Whatever I get, that's it. This is 1 minus 18 plus 4, so that's 5 minus 18. It's minus 13, right? Did I do that right, or did I? Let's see. Okay, what if I had chosen the other path? D minus VC still, right? But suppose instead of going right, down, or left, I go left, down, and right. And I stop when I get to point D, right? Let me choose that other path. And I better get the same answer. So I start at this point, C, and I go to the left. When I go to the left, I'm going in the same direction as this current. So what should I write down when I go? What is the voltage across this resistor? And I'm going in the same direction as the current. What's that? Minus 1 times 4, right? Yes? Yes? Because I'm moving in the same direction as the current through it. So it's minus 1 times 4. I get here, I turn down, and I go this way, nothing happens. Now I'm going to go this way in the same direction as this current through this resistor. So the voltage across it is going to be 1 times 2, and I'm going in the same direction as the current. So it's minus 1 times 2, right? Continue my trip, and then I go through this battery from plus to minus. So I'm dropping by 7. So minus 7. And then I stop, and that's it. I don't set that equal to 0 because I'm, so then this is what? Minus 4, minus 2, minus 7. So 4 and 2 is 6, and 7 is 13. They're all negative. Same answer. Yes? That's how you do that. One more thing that I like to say about this problem is the following. You see, you might wonder, why did they put this 1 ohm resistor over here? Notice 1 ohm resistor over there, next to that one. And 1 ohm next to that one. So what's up? What's up with those 1 ohm resistors there? Right? So here what happens is the following. That was for the trip, right, that I was taking. Okay, what happens is the following. In reality, in real life, batteries have an internal resistance. And when I use this textbook as a student, the batteries with internal resistances, like this battery, for example, this battery was labeled like this, with the EMF over here like that, which is 7 volts. And then the internal resistance was written like that. And that was written with a small r. It's like the resistance between the 2 terminals of the battery. And then you could see that that's inside the battery. It's, in the battery. So what the new authors decided to do was they took it outside, and in this picture, they took it outside that. And then they put that internal resistance over here. But now, that's really, now the battery, because they took out, now the battery is all of this. That's the battery. So in these pictures over here, this is actually the battery. This is the battery. And this is the battery. So I'm going to erase this now, right? We're done with this part, or this discussion. So, let's call this battery That's a 1, that's a 2, so I'm gonna call it number 3. I'm gonna call this battery number 1, because it's got the 1 over there. Just, you know, we can call it anything we want, but this is just battery number 2, because there's a 2 over here, only that, right? So then there is this sort of question that sometimes you encounter in exams, in quizzes, in homework, in textbooks, right? What is the battery voltage for battery number 1? So what do you mean? I mean, if you just look at the circuit, you might say, oh, it's 20 volts. It's not 20 volts. That's not the voltage across the battery, because this resistor is really inside the battery. So what you do is this. Okay? First of all, so I usually express that as a positive quantity. So which of this, so I'm going to think of this as one terminal of the battery connected to the negative terminal, right? And this is really like the minus, and this is like the plus, because that's connected to the plus terminal of the battery. Which of these 2 points do you think is at the higher potential? In fact, this was point A, right? There's no potential difference between that and this point, and that's the same, pretty much the same as that. Now, point B is here, so that's point B, but then this is different. So I'm going to call this, how about I call this, should I call it E, just so that it's not confusing with the other parts when I call it C and D? What if I call that E? Right? So the potential difference, the battery voltage for battery number 1 is the potential at A, which is, you know, connected to the plus, right? Minus the potential at E. So the battery voltage for battery number 1 will be the potential at A minus the potential at E. That's the battery voltage. So going back to the problem that I just solved, I look at this and I see the minus sign, and what do? I start at E and I stop at A. So there are a couple of things you can do. I can start at E and I can go straight to A like this, or I can start at E and I can take a trip around the circuit and end up at A. Any path will do. I think it's easier if you just go through the battery like this, because then you just have this and this term, as opposed to all of these other terms where there's more chances of making a mistake. Yes? So what would that be? So I start at, I want the battery voltage for number 1, right? I see, I'm going to call this E, right? That's next to the negative one. That's plus, so this should be higher than this. So I start at E and I move towards A. So I'm going to go this way, right? That's me. So what should I write down? If I go, I go from minus to plus, what do I write down? Plus 20. And then I go through this resistor in the same direction as the current. So what do I write down? Minus 1 times 1. And then I stop because I got to the other point, right? So the answer is 19 volts. That's the voltage across the battery. The EMF is like, it's like the voltage across the battery when there is no current through the battery, or when there is no internal resistance, which is an ideal battery. But in reality, the batteries have an internal resistance. You know, an ohm is not much, but it's there. What if I ask another question? What is the battery voltage?
Oh, Professor, for the top one, you solved for battery number 3.
Oh.
Not number 1.
Okay, thank you. I'll just change this. Thank you. Simple correction. Thank you. So I'm going to do number 2, which is down here. So you know, which of these 2 points is going to be at the higher potential? The one on the left or the one on the right? This point on the left or this point on the right? The one connected to the positive terminal is the higher one, right? Should be this one. And that should be point A. And this one, I'm going to call it, did we call it D a long time ago? Just to be consistent with the previous question, which has nothing to do with this one. But. So the voltage across, now I'm going to be careful. Battery number 2 is this one down here. So it will be V at A minus V at D. So what do? I start at D and I stop when I get to A. So I start at D and I go this way. And I go towards A. So what do I write down when I go across this battery? +7. And then when I go through this resistor, it'll be what? +2 times 1, right? So it'll be 7 plus 2 times 1. So that's going to be 9 volts. Okay, now I'll do number 1. So number 1, I think I don't know if I called this one, this was point C or maybe point C was there. I don't remember. Okay, here or there?
There, the one that you have right now is C.
This is C. And then this one will be, that would be the same as B, right? So for the battery voltage, for battery number 1, should it be VC minus VB or VB minus VC?
VC minus VB.
Yeah, the higher minus the lower one. So it would be VC minus VB. So I start. Where do I start?
At B.
Oh, and I said it's B, right? No, it is D. I'm doing number 2. No, number 1. Number one is this one. It is B. So VC minus VB, like that. So where do I start? At B, right? And I stop when I get to C. So I start at B and I go to C. So this is me, and I'm going to go this way. So what should I write down? I start here. When I go through this one, I should write what?
+18.
+18. And then?
-1 times 1.
-1 times 1, right? In other words? Let's check one of these 3. By not going across the battery like I did, but let's use the rest of the circuit. Which one would you like me to check? Battery 1, 2, or 3? 2? I heard 2. Did you say 2? Okay, good. And battery 2 is this one, right? Okay, so instead of taking this trick for battery number 2, it's still, for battery number 2, it's still VA minus VD, right? And where do I start? At D. Where do I stop? At A. But instead of going through the battery, I'm going to use the rest of the circuit. So I will start at D, right? So I'm going to start, and let me write it down. So I'm going to start at D, and I'm gonna stop over here. But I don't wanna go through the battery, I already did that, right? Let me just take another path. What if I go on the outside, all the way on the outside? So I'm gonna go this way, that's me. So I'm gonna write what? Minus 2 times 2, right? And then I'll go up, 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 and then
Minus 1
minus 1 times
times 6.
6. Keep going, and then from minus to plus it'll be plus 20. Keep going. When I go to the resistor, the internal resistance of the battery, it will be minus 1 times 1. Keep going. Oh, and then I stop, right? And then I stop. So how much is this? So this is what? Minus 4, minus 6, plus 20, minus 1. So that's minus 10, minus 11, plus 20. Same answer. So,